In this video, we're presented with an indefinite integral secant times tangent times e to the secant of x dx. And the first way I want to approach this is informally. In other words, I want to recognize a function of a function in this integrand sitting right next to the derivative of the inner function. And this is a way of recognizing the chain rule operating backwards, and we should be able to guess the antiderivative. So the function of a function I'm talking about is right here. The secant function is the inner function, and I'm taking e to the secant function. Well, the derivative of the inner function happens to be sitting right out in front in the integrand. Now I can recognize this as simply being a result of the chain rule. And my antiderivative is going to be the antiderivative of this piece where the side effect of the chain rule of differentiating the inner function has already been taken care of out in front. So what do I differentiate to get e to the secant x? It's just e to the secant x, and then the chain rule takes care of the other piece. And that's it. Now if I check my answer, and that's partly for accuracy, but partly just to improve my intuition for how the chain rule works, forwards and backwards, I differentiate e to the secant x, and I differentiate that with respect to the interior function, treating it like a single variable. And of course, e to a variable is a very special function. When you differentiate it, you just get a copy of itself. And then the chain rule says, now you've got to differentiate the interior function with respect to x, and the derivative of secant happens to be secant x, tangent x, and I get back to where I started, so we're good. Now, the formal approach still requires that you see a function of a function and identify what the inner function is, and you at least have to have some hope that the derivative of that inner function appears elsewhere in the integrand. And of course it does that perfectly in this case. Once I've identified that inner function, I say let u equal that inner function. Then du is the derivative of this function, secant x, tangent x, multiplied by dx. And then I take a fresh look at my integral. And I realize the secant tangent dx can just be replaced with a du. And that e to the secant x can be written as e to the u. And I'm ready to guess the antiderivative, which again is just e to the u. And then I replace u with its definition in terms of x, so I have e to the secant x plus c, and we get the same result either way. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.